we are going to look at solving systems of equations using matrices. And so you can see we have two linear equations on the screen. We have 2x plus 3, y equals 2, and 4x minus 9y equals negative 1. So first things first, we want to go ahead and take our two equations here, and we want to rewrite them in their matrix form. So we'll come over here, and we're going to write that coefficient matrix. That's going to end up giving us 2, 3, 4, and negative 9 as our coefficient matrix. The next part is really going to be just taking the variables that we have here, and this is real simple. We only have two. We have an x and we have a y, and that could be any letter, but I guess the most important part is we look at how many there are. So in this case, we're going to have x and y. It's really important that you match up here, and so the x, this section here, is our x variables and our coefficients, and this is our y coefficients. And you can check that back over inside the equation here. So the 2 and the 4 are for x, and the 3 and the negative 9 over here are for the y. And so make sure we do that, and then we put the x on the top and the y on the bottom. That's going to be equal to our final matrix, which is our constant values, and that's going to come from the other side of the equal sign. And so we end up having 2 and negative 1. It's really important that we make sure to start off with the equations in this form, where it's ax plus by equals c, standard form. You want to make sure it looks like that. That way, it's kind of really pre-made to kind of go directly into the matrix equation, right? So next, once we've got step 1 completed, so if we can just call that, this will be step number 1. The next part is to go ahead and we talked about this in class. The basic principle behind this is we're going to end up multiplying on both sides of the equation. We're going to multiply over here and over here the inverse of this matrix. And so that's really important so that we can get that to be just x and y equals another value. And so we're going to go ahead and find that inverse. And so if you remember from class, our inverse formula, so A inverse is equal to 1 over the determinant, we'll write that down, is AD minus BC. And then the next part was where we had that matrix that we kind of rearranged all the numbers and changed some signs. And so if I'm looking at, this is my original matrix, so you can call that matrix, that's A. And so if we're going to go down here and find that inverse, we'll go ahead and we're going to swap the A term, 2, and the negative 9. So negative 9 goes here, and 2 is going to go there. Then we're going to change the signs on the other diagonal. So we have negative 4 and negative 3. And now I'm ready to go ahead and multiply through. Let's go ahead and I want to erase that little formula here, and we're going to fill in the determinant. So if we can find that determinant, I'll do it over here. So it's going to be 2 times negative 9 minus 4 times 3. And don't go too fast with this. I've seen a lot of times where people get their negative signs lost and they don't remember if it's positive or negative. And so this is going to be negative 18 minus 12. So that's going to give me a total of negative 30 as my determinant. So that's going to come right here, negative 30. So if you remember, and I'll write the generic formula right underneath it. I started to do that. It's AD minus BC. And here it's going to be D and then A. Those two get swapped. And then here, we don't swap them. It's just going to change their sign. So the opposite of C and the opposite of B. So just whatever sign they were to begin with, we're just going to swap those two. Let's go ahead, and I'm going to go just distribute through here and simplify the fractions if I can. So we're going to end up with the same size matrix. So 9 over 30, I'll go ahead and write it out here. So this is going to be, I'm writing positive 9 over 30 because they're both negative. So negative over negative gives me positive. This one's going to give me 3 over 30, and then 4 over 30, and 2 over 30. If we reduce those to lowest terms, 9 and 30 share a common factor of 3. So that's going to be 3/10, and then 1/10, and then 4 and 30 have a common factor of just 2, so it's going to be 2/15. And then 2 goes into 2 once, and 30 15 times. So there we have our matrix. Oops, I forgot something. So here, now, okay, this is good practice. So make sure, one of the things that I'm used to doing is once I've finished some computation, it's a mental check that I know that I'm prone to losing my negative signs. And so I have a mental check to go back, a habit that I've developed to go back. I know this was negative, and so I'm going through, I see here that if I'm multiplying by a negative number, I know that all of the signs will change. So I noticed that in my final product, I had all positive numbers, but that shouldn't be the case. These 3 should be positive, but the last one should have been negative. So I'm going to go back in, and we'll add that negative sign where it's supposed to go. Just double checking that I've done the multiplication right, not dropped anything. Because if I lose that negative sign, well, after this point, everything is going to be incorrect anyway. So this would be step number 2, is finding that inverse. Now, of course, this is working it out by hand. We're going to talk about how to do this with a calculator in just a minute. So now that I've got, let me go too far. Now that I've got the inverse found, I know, and I'm going to kind of write this all the way out. There's a lot of this that you can kind of skip over when you're doing it for yourself. So we're going to multiply both sides. So let me write down the formula that we're really working with. So if we start out with a form that looks like this, the coefficient matrix times our variable matrix equals another matrix, we'll call that one B. That's our constant matrix. If this is what we start with, and you can kind of see that is where, if you come back up here, that's where this step started off, and we have that form right in here. So this is your matrix A. We'll call this matrix. This is your B matrix. And X, of course, is kind of self-explanatory. That's just our variable matrix. So this is the form we have here. The method, the concept, the idea that we're looking to do is we're going to multiply A inverse times A, and the X is still here, we haven't changed that, equals, and this is the same for any equation, whatever you do to one side of an equation, you must also do to the other side. And so in order for this equation to stay equal, we're going to do this. But we know that A inverse times A automatically gives us the identity matrix. All right? And if I multiply the identity matrix times the variable matrix, then it isn't going to do anything. It's simply going to be just this matrix. And so what I want to do is, this is what I'm interested in figuring out. If I can figure out whatever that is, then that's going to be equal to my solution. So we're going to go ahead and we're going to recreate that, or we're going to calculate that product by bringing our values down. So we're going to come down right, let me draw a line, right here. The inverse, so 3/10, 1/10, 2/15, negative 1/15. And so this is the inverse. So this is the A inverse right here. Now I need to bring down B. So B was our real small matrix. That was just our constant. That was here. You can see that's 2, negative 1 right up top. So we're going to have 2, negative 1. Next thing I would do, I'm going to write my matrix sizes down. This is a 2 by 2. This is a 2 by 1. So I know it's possible because the inner dimensions match. But really more what I'm interested in, and I knew this would already work, how big's my solution going to be? My solution matrix is going to just be a 2 by 1. Alright, so now that we've got that written, let me move that, because that is just going to get all in the way. So we're going to come down here and work with it. So I multiply through. We're going to go ahead and we're just going to use basic matrix multiplication. So we're going to go across the top, down the first row. And so we're going to have 3 over 10 times 2 plus 1 over 10 times negative 1. And that will be equal to one value. And then we have 2/15 times 2 plus negative 1/15 times negative 1. And that's equal to something. So let's work this out. We have, let's see, 5. Oops, that's not 5. That is 6. So 3 times 2 is 6 over 10 minus 1 over 10. The next one's going to be 2 times 2 is going to give me 4/15 minus negative, because you have the product negative 1 times negative 1, 1/15. And what we can see, that's going to give me 5/10 or just 1/2. And this is going to give me 5/15 or just 1/3. And so if we kind of think about that, our equation, we have x, y, that was what was left on the other side, is equal to the matrix 1/2, 1/3. So x is equal to 1/2, y is equal to 1/3. That is how you would solve an equation, or solve a system of equations, using matrix multiplication and matrix inverses. And so really that's this section down in here. This is the method, this is the idea, and this is just the algebra of multiplying two matrices together. Once you get down to this, so let's call this this will be our step 3. It's just multiplying that out and finding a solution. All right, this last part is nothing special. It's just matrix multiplication. If we wanted to check that, how would we take that into the calculator? We'll do that in the next video.